All right. Yeah, my name is Reza, CTO at Synonym. Let's go to the next one. So yeah, Synonym, we've been working on Lightning, and our flagship product is called BigKit. BigKit is a non-custodial Lightning app. We launched last year. It wasn't quite up to scratch, but this year we made massive progress, and there's a treasure hunt going on, and we've seen people, get some sats, so it's been going well. Yeah, so BigKit is a non-custodial Lightning app. Within BigKit, we have LDK. LDK is a full Lightning node running in there. There is slash tags integrated inside of it. Slash tags is a kind of a decentralized app platform where we're going to use that to express how we feel how the decentralized web will look like. Within BigKit, we have also Blocktank, our LSP, Lightning Service Provider. This service provides liquidity to BigKit, so our users have good experience when using Lightning. So within our scope of work, we are focused in non-custodial Lightning, where we work closely with the LDK team to fix bugs and kind of push forward non-custodial Lightning for users. We're focused on user experience. We're not only focused on the hardcore Bitcoiners who already know how all this stuff works. And with slash tags, we want to basically give a way for users to have their publication, their social media apps, their identity. So it's the app layer of our ecosystem. So within these two areas, we have kind of we're working in an area where actually the whole industry is focused on. So these apps that have they are holding their money, so they've got the keys to they hold their keys. They also hold the keys to their identity and their data. So I think we're in a good position to show what actually goes on in these applications, where it's just not us just building these. Everyone's kind of building these types of applications. And in this talk, hopefully you'll understand what goes on under the hood, and you'll also, if you're a user, if you're building one of these apps, you'll understand what it takes to build it and the different components of it. And also maybe if you're just a user, you should know that hopefully you're not going to get scammed by people pretending if their app is non-custodial or decentralized, or they're secretly posting everything to a server which we don't know about. So BigKit, the stack that we have is, we'll start with on the left, we have the LSP stack. Our LSP is called Blocktank. And so we run it ourselves. The end goal is to, we actually are spearheading the LSP spec. So you're not going to be locked into Blocktank. There might be different apps out there where the apps is actually locked into the LSP. We want the user to eventually pick their own LSP. We don't want to be the only one. I mean, the end goal is, with mobile apps, you always have to have some kind of a server running somewhere. But the idea is you're not going to be locked into it. So you should be able to run all the different components, the server requirements. And I'm actually going to go through, for people that want to build these types of apps, different platform trade-offs. So we chose to build a mobile app, but if you build a desktop app, the kind of the technology stack will look kind of different. If you build a progressive web app, which has kind of gotten a bit of traction recently, that will also kind of affect your overall stack. But basically on the left, we have the LSP API. The LSP has its own Lightning node. It's got a Bitcoin node. So that also, if you're building one of these Lightning apps, if you don't have an LSP integrated inside of it, you're kind of expecting your users to become experts in Lightning node management, which is not fair, and it's really probably not going to get much traction amongst the normal users. So that's an integral part of any of these types of applications. The next one is the Rapid Gossip Sync server. So we use LDK, and the Rapid Gossip Sync server, the RGS, is like a a requirement again for user experience reasons to for LDK integrators to give a good experience on LDK, because as your phone is offline, you're not going to know the full picture of the lightning graph. So as your phone goes offline, channels come and go, and they come online. They have to kind of sync with the node to get the latest graph, and it could be kind of slow, and it's just not a great user experience. So we have the RGS server running there, but the RGS server, again, the user could pick their own RGS server. They don't have, we run one for convenience reasons, but it's not required to run it. The user could run it themselves. Different apps may have different Lightning setups. So, for example, Greenlight has gotten traction recently, but Greenlight doesn't have an RGS server, but you require the cloud nodes on there. So, depending on your Lightning setup, you could kind of tweak this, but you kind of end up in the same scenario. For on-chain, we use Electrum. Electrum is kind of like, I guess you could call Electrum and RGS kind of the same thing. RGS is for Lightning, and Electrum is for on-chain, where it just gives the on-chain data. The slash tags relay. So regardless of whatever Noster or Keat or whatever, or any of these decentralized applications, if you're building them, you're going to have some kind of a relay system, because your phone is offline, and when you come online, you need someone to kind of give you what you've missed out on. And we have a relay. If an app is like on Noster, it's got the Noster relays, and the Hole Punch guys, they were actually announcing their blind mirroring, which is again some form of a relay. And also, lastly, we got the encrypted backups, which is kind of allows the BitKit user to restore their app and holds their Lightning channels, so in case they lose it, they could get it back. So this is the overall picture. The goal is to always allow the user to run everything themselves. We provide some services out of convenience. It's never supposed to be locked in. So if you're using an app where there's some lock-in in there, you should always think about it. And again, it's all about trade-offs. I'm not saying this is the right way and this is the best way. This is just what we've chose, given the trade-offs and what our values are. So the platform trade-off. So the browser-based apps have recently gotten some traction. And the reason is the mobile native world, again, there's some trade-offs there. The native apps, you get the App Store, it's easy onboarding, it's great, right? But the App Store ecosystem is really, they take down apps all the time, and it's hard to get on there. They don't really understand Bitcoin, and they rather just not have this stuff on there, to be honest. It's just hard for them to understand how it works, and it doesn't really fit into their models. So people have built these progressive web apps, but the web standards are great, but the web, even though it's getting close on mobile, it's still not amazing. It still doesn't match the native experience. And there's technology limits, so DNS WebSocket, WebRTC is all you can use. You can't have raw TCP sockets. You're kind of locked into the limits of the browser. So, but it's still open. The web is one of my favorite platforms to build on. It's free, so you could just put up a website. Your domain name could be seized, so it's not completely uncensorable. Your static IP could be taken from you, and people can't find you anymore. So, there's some trade-offs there. Native the native apps, like I said, the closed ecosystem, but they're really powerful. You got all those sensors on your phone that you could leverage. There's a lot of cool apps you could build using those sensors that you can't build with the web app. And if you have desktop apps, well, desktop apps are really great. You have full access to all the APIs of the computer, but you can't build certain types of apps. Like building a photo sharing app that's a desktop app, it's kind of stupid, because you don't want people to walk around with their laptop taking photos. So as you're building these apps, or as you're using these apps, the developers behind those will probably have to go through all these decisions. So let's say you're building some of these, or you're using one. You understand the trade-offs for the platform. Now you come to the app, the actual data layer, and your identity and how those work. So I've just classified it as the communication, aggregation, coordination, and probably identity as well. Again, there's so many of these, and there's way more actually. And this ecosystem has been around before, like Bitcoin as well. So people trying to build decentralized platforms for forever. And yeah, again, some of these are suited better than others, depending on what you're building. And each of these have different communities. They have different values and what their goals are. And I like to kind of think of it as they're decentralized walled gardens, because even though they're all keys, they're all key-based, they're not interoperable with each other, which is kind of bizarre. I mean, the whole point of this being open source is that, oh, I wish I had just a keychain and I could use any of these, and I shouldn't really care about which ecosystem I'm on. And there's architectural differences, so the developers of these ecosystems have made their own choices about what they think is the right way forward. And yeah, we've been working on slash tags, and I'll go into it a bit more about how what we are thinking about, how we're thinking about these problems, and what given our research into this work and where we've landed. So to kind of show kind of prove my point that there's like really no perfect system and there's always trade-off, there's this concept called the cap theorem. And the cap theorem basically is it's kind of a proof that you can't have a perfect system. So all those different platforms, they've made some of these trade-offs in their system. So what it really means is you've got the three circles, they don't overlap all together. You could only overlap two of them at once. So consistency means your data, when you fetch it, you get the correct data always. Availability, it means that you want your users to be online. So Lightning has like availability requirements. So if your user is not online, you can't pay them. Partition tolerance is a requirement for any distributed system. So in our world, it is a requirement. So it does make things a bit easier. So we don't have to kind of think about partition tolerance because we always need it, but it doesn't actually take away from the final two, consistency and partition tolerance. And partition tolerance and availability. So, for example, in a pure peer-to-peer app, you require the other user to be online, right? And that means your application, when you, for example, you update your profile and it's a peer-to-peer profile, you go offline, the users can't know your updates that you've made until you come online, right? So now you put a relay in there. So that kind of makes your system move, change its cap theorem optimization. So even though there's limits in the actual theory for this, there's ways around it. So what we've thought about as an analogy and as looking at other industries which have had the same problem, in slash tags, we're kind of using the telecom industry as an example. And although this is not fully rolled out yet, it's kind of still in R&D and development. But if you, as an example, if you think about your phone, right, it works on 5G, 4G, 3G, Wi-Fi. It's able to pick the network dynamically, and you may have different settings on it. So you might turn on your Wi-Fi. Oh shit! If you might turn on your Wi-Fi, so if you come here, it automatically connects to the Wi-Fi. But if you don't want to connect to this Wi-Fi because it's slow, you can turn it off and it'll connect to 5G or 4G. It's kind of smart enough to know what network to be on. So what we're thinking about is kind of bringing the same concepts to decentralized app development, where it can detect, if you're not being censored, there's no reason to use a slow network, right? If the network should detect, oh, I'm being censored, I'm going to go to full peer-to-peer mode, and the user is able to find me. So it should all be hidden away from the user, and the actual user may have some preferences, just like how, oh, I want to use Wi-Fi, I don't want to use 5G, might kill my battery. So what we want to do is, and what we're hoping to achieve is kind of hide away the complexities, all these different platforms, and hopefully make it so you can operate and exist on any of these, as long as there's the modules are built, the bridges are there, so you could, if a user is on a certain protocol, you could post to it, you could interact with them. Because all these different protocols and platforms, they're all open source, they're all key-based, so in theory, there should be no reason for them to not work all side by side and take advantage of the strengths of each of them. So let's say you've built your the app layer, you've decided what you're going to work on. The next step is your kind of your non-custodial Lightning. There's like three main ways to achieve non-custodial Lightning today. There's the remote nodes system, which is you ask your user to run a node at home or on a cloud somewhere. Ideally not a cloud, because if it's on a cloud, then Amazon, whoever, could actually take your funds. So they have a remote node, you have your app, could connect to the remote node. This is like probably the easiest way to do it as a developer, but for users it's hard. You kind of require them to have another Lightning node running somewhere, hoping it works well, and hoping that it's got like LSP integration and the channels are working fine. We chose not to do this because our app is a Lightning wallet, so we want hopefully to be the user's main wallet. So we opted for the second choice, which is the embedded Lightning node with LDK. So LDK is a full Lightning node inside of it. And with the LSP integration, it's really easy for the user. If you try it, as soon as you install the app, the Lightning node starts connecting to the Rapid Gossip Sync, then Electrum, all the components all start working. The user doesn't need to care about or think about, oh, is my node at home working properly, or is my connection to home, or if I'm using Tor to connect to it, or whatever I'm using, it's all working. So it's all in the app, and it kind of puts the responsibility on the developers to kind of give that good experience to the user. But the downside is that it's quite difficult to actually embed a full Lightning node inside a phone app. It's getting better, but it's still, we've got some way off to make it easy for just any developer with just average skills to kind of pull it off. We've been going at it for over a year now, and it's still not 100% there. And the final one is with Greenlight. So Greenlight is looking pretty good. It's the newest kid on the block. So the way it works is your app holds all the keys, and the Greenlight operator runs the node. And anytime anything happens on your node, the user has to sign. So the node, the cloud operator can't actually steal any funds from you. So that's great. But you're still kind of relying on the third party to run that node for you, which they can't steal it, but if there's outages, that means you can't pay. And as we've seen, sometimes there's outages. When AWS goes down, like half of the internet goes down. And if Lightning is supposed to be, you could just spend it, it's supposed to be like cash, you don't want to be subject to that. At least, ideally, you don't want to be. But again, it's all about different trade-offs. A developer that wants to only focus on providing really good user experience, and the trade-off of just relying on a third party and being okay that it's non-custodial with Greenlight, I mean, that's fine. But it's good to understand what are the actual trade-offs that happen underneath. There are ways to improve the non-custodial Lightning experience. It's just this ongoing thing that's just going to keep getting better and better, hopefully. We have multiple node setups that we've been kind of experimenting with and thinking about. This is when the Lightning state is put on a cloud node somewhere, and when different apps use the same node, they share the same channels between different apps. So this is kind of achieving the same Greenlight experience, but with LDK. We also have we have different ideas about slash tags to kind of help kind of ease the UX issues with non-custodial Lightning, but I'm not going to get too much into it today. But for example, within BitKit, we allow a user to pay to a public key, and behind the scenes, it's able to find the different payment preferences of the user and to just settle on a final payment. Payment method, and it has different plugins, so you could ideally pay to two different. If I have a node running on my phone and if I have a node running at home, I could pay to a single public key, and behind the scenes, it could figure out which node is available to accept payments and just pay to that node. So yeah, overall, to build these different types of Lightning apps, as you've seen, there's different trade-offs, different components, and in order to kind of get to the final user experience and to kind of understand how these applications work, you have to understand the different components. And I don't think, as it stands now, the different components are going to change that much given the current technology. And yeah, so that's pretty much it. And yeah, go ahead, start building.